So hey guys, welcome back to the channel. We are starting our DSA grind session 3. Hope you all are doing good. So without wasting any time, let's just start the session. So the first question is find maximum value of sum, which is I star array I with only rotations on the given array allowed, right? So we have given some array and we can rotate its values, right? Rotate left or right, rotation does not matter, and we need to maximize the sum, which is I star array I. What that means is key for this I is 0, so 0 times 1 plus 1 times 20 plus 2 times 2 and 3 times 10, right? So we need to maximize this sum, and how can we achieve that? By rotating. Okay, we can rotate this array. So from that it means key array would start from 20 to 10 and 1 will go to the right, then 20 times 0 or 2 times 1. You got the idea, right? So how to solve this question? Now the question arises. Let's refer our notes for that. So for the first example, which is maximum value of some I star array I, this is the array 122 and 10, and 1 times 0, 2, 3 times 1, 2 times 2, and 10 times 3. That would give us 64. If I do a one rotation, right? So 10 will move up to the front. So 10, 122, 10 times 0, 1 times 1. This would result 47. If I do another rotation, 2 will go up front. So 2, 10, 120, and for that the answer is 72. If I do one more rotation, it will be 22, 10, 1, and for that the answer would be 25, right? So we need to do all these rotation and we need to get the maximum value of the sum. One brute force way is key just rotate just have every possible rotation, get the answer. So that would be big of nk, where k not nk in n square, because of we have to do n rotation, right? So brute force check all rotation and sum. So we need to optimize. So can you see any patterns like add, sum, minus? So we need to check whether can we see any pattern or not, right? So from this rotation, is there any pattern, right? So 1 times 0, this becomes 1 times 1. 20 times 1, this becomes 20 times 2, 2 times 2, this becomes 2 times 3, and 10 times 3, which becomes 10 times 0, right? So every number is getting added by 1, right? 1 times 0, 1 times 1, 20 एक बार था, now 20 is 2 times, 2 times है, तो यहाँ पे 2 3 times हो गया, but the last number that is reduced to 0. Okay, so we need to utilize this pattern, right? So from the previous rotation, I can extract the new rotation, the sum of new rotation. Okay, so the pattern is sum minus size time last element. And what is that? Well, this is the last rotation. To get new rotation from it, I am just adding sum to it, right? So sum is 120, matlab 1 times. So 1 is 1 times, yes, 1 is adding 1 times, 20 is 1 times, so this become 2. 2 is adding 1 time, so 2 becomes 3, right? And then 10 is adding 1 time, so 10 becomes times 4, right? But we need to reduce it to 0, right? So minus size 10 times 4, 4 is the size, right? 4 times last element, and last element is 10. So makes sense. We can get all rotation by it. So this is big of, so by this, and this is big of n. We only need to calculate sum for the first rotation, then we can extract for all other rotations for the sum, right? So first rotation array sum result equal to summation of I star array I, and for n minus other rotation result would be the previous rotation plus array of sum minus array n minus j, where j is the number of rotation, right? If the rotation number is 1, so for the next rotation it would become, it is going to subtract the last element, which is array n minus 1. You can also refer the GFG link and have the full solution. Let me just open it a second. So this is the coding part, and let's just see the code. So we are calculating, so let's look at the coding part, and the code is here. So we are calculating the sum for the first rotation, and that would be, this is calculating the whole sum of the array, and this is the result that we need to return, which is I times star I star ar I, summation of that. Then this would be the max value, and then for once a n, for all the n minus 1 rotation, because we already have result for first rotation, what we are doing is we are getting result from the last rotation plus array sum minus size of the array times array last element, which is n minus 1 for the first time, then n minus 2, and so on. And if this rotation sum is greater than the previous one, so we are just updating it. So yeah, that's it, and the time complexity is big of n. So that's it for first question. Now move to the second question. So the second question, which is duplicate number, we have given n plus 1 integers which are in the range of 1 say n. So if the range in the 1 say n and n is equal to 4, so n equal to 4 we are given in the n plus n equal to 4, so 4 plus 1, 5 integers. So we will have 5 integers, okay, and the range would be 1 say n, so it would be 1 2 3 4. So 1 2 3 4, it is showing no, that is incorrect. 1 say n, So our next question, which is duplicate number, we are given some range and the number set of integers. So let's just move to lead code for more clarity. So yeah, this is the question part. Nums containing n plus 1 integers, where each integer in the range of 1 say n. There is only one repeated number in the array. We need to return that repeated number, okay? And you must solve the problem without modifying the array nums and uses only constant extra space, right? So what is 1, 2, 3, 4, 5? So for this, the size is 5 and it is showing key it would have n plus 1 integer. So n becomes 4 here, right? N plus 1, so 4. So 1, 2, 3, 4, you will get all values between 1 say n. So 1, 2, 3, 4. Now we need to do, there are two 2's in it, right? So return 2. In this, the element which gets repeated is 3, right? So return 3. So one way is to just traverse on it twice, so big of n square, the brute force way. Another could be the sorting, so that would be big of log n, but we need to do it in big of in linear time. Yeah, we will look for some more optimized solution, right? Can you solve the problem in real runtime? So yeah, let's try. Let's move to the note section for more clarity. So this is the note section, and brute force, can we utilize some property, means like answer equal to sum of n elements minus sum of array? Can we utilize, or can we do something like that? Okay, I will calculate the sum of n elements then minus sum of array. Can we? Just think about it. It can be 3, so the sum logic that won't work here, so we need to think of something else, right? So let's move back to our notes. The sum logic won't work, so there is a cycle and I'm telling you that there is a cycle in this array. So what is a cycle? Like, let's just treat it nums equal to 1 3 4 2 2. Okay, so 1, if I am at 0th index, okay, and the value is 1, so I'll move to the 1 index, the value is 3, I'll move to the 3 index, the value is 2, I'll move to the 2 index, the value is 4, I'll move to the 4 index, now the value is 2, I'll move to the 2 index, value is 4 2 4 2 4 2. Yeah, so there is a cycle. You can see that 1, then I move to 3, then I move to that 2, and then I move to the 4, and then I move to the 2. So after that there is a cycle in it, right? Or let's just say any other cycle. So what we are gonna discuss here is tortoise and hare algorithm, and what is that we will see. So there is some let's just say this cycle here, okay, 1 2 3 4 5 and 6, and this is some distance x. That means from where the cycle is started, and this is some distance k dash where two things will meet, and those things are tortoise and hare. So it's basically there are two variables or pointers, they are tortoise and hare, and that there is a race between them, let's just say, and they will meet at some point, right? Hare being fast, he will run at the twice the pace of the tortoise, right? So that's the thing. Tortoise and hare will start from here. Tortoise will move one step, hare will move two step. Tortoise again move one step, and hare will move again two step. And they will both meet at some point in this cycle. Makes sense, because hare fast, he will keep loop in this cycle, and whenever tortoise reach to the cycle, he will meet at some point. So now we will discuss something like proof of about it. But this is what tortoise and hare algorithm is. And at that point, when they meet, what we do is we traverse the tortoise, we make tortoise to go on the initial step, on the initial line, and then we move tortoise by x distance, and then hare will also move by x distance, both at the same step. And at that point, wherever they meet, that would be the start of our cycle. Okay, so it's a little complicated, I haven't discussed much here, but it is something you can find easily on the internet, right? So I'm going to discuss the proof here. It is also asked in the interviews, and one of my friend was asked this question, right? So we are going to discuss the proof. The distance of hare is equal to twice of the distance of tot. Makes sense? Its speed is twice, he's going to cover the distance twice in the twice amount, right? So distance of hare, and they are meeting at this point. So x plus, I'm talking about k dash plus x plus k dash plus, and now we don't know how many cycle he will move in this loop, right? The hare. So for that, I just take the h number of cycles he will cover in this loop, and the cycle length, one of the cycle length is k, right? And for the tortoise, twice of t tot, which is x, and it is meeting at this point to x plus k dash, and we also don't know how many cycle that tortoise will cover in this, so I'm assuming it by t, and for the cycle length it is k. So makes sense, normal mathematics. K plus dash hk, and this, so twice of k dash plus x, and one k dash plus x got cancelled. 2 2tk minus hk, and k common ले लिया, so 2t minus h. This would be an integer, right? Because 2t minus ht would be an integer, so this would be an integer. So k dash plus x equal to k times some integer. So what does that mean? K is the length of the cycle, right? So k dash plus x is some multiple of cycle length. So from that, what we are getting on, right? Let me just show you. Now both are standing at this point, the k dash, which is a 4. We assume that this is the meeting point. Now I'm telling you ki what this algorithm does is ki total will move back to the 1, and now totals will cover x distance. Okay, so here will also cover the x distance, and now they both meet at this point. But how I am so sure ki they will meet at this point? Why? Because we have already covered k dash. Now whenever I cover x distance, I will cover some number of times of cycle. Don't know whether it is 1 or 2. That means k dash, if I cover x, there can be possibility I will again reach, yeah, or there can be possibility I will cover 2 cycles and I will reach this point. But it is for sure that it is a multiple of cycle length k dash plus x, so they both will intersect at this point. So that's the algorithm is about. When dot move x distance as k dash plus x is a multiple of cycle length, here will move x step from its initial position, which is k dash, as multiple of cycle length, it will reach start of the where both will intersect. So that's it, and let's just move to the coding section. So this is the coding section. I will explain you the code. What we does is key at initial they start from 0, so tot equal to 0 and here equal to 0, while 1, the tot will move by 1 step, which is nums of tot, and here will move by 2 steps, nums of here, like in this case. So for this the tot will move to 1 index, which is 3, and here will move to the 1 index, which is 3, and then 3 for, so 3 index, 0 1 2 3. So here will be pointing to this and nums will be pointing to this. So here will move 2 steps and nums will go. If tot equal to here, that means they will both meet at some point in the cycle, just break. So after this loop, we are sure that any cycle exists, but what is the starting point? Why are we focusing on the starting point? Because at the starting point, that is the element that is getting repeated, right? And so after that we move tot to 0, and while they both are unequal, what we're going to do is we are going to cover that x distance, right? So we will move both by 1 step, and whenever they are equal, we will just return the tot. That is the our duplicate element. You can take a case and try to rerun it. I just explained you the code and the logic behind it. So let's move to our next question now. So next question, which is jump game. You have given such array and you need to reach at the last index, right? And the question is ki whenever you reach this step, let's say 2, so you can take 2 steps in this direction. So you can be at 3, you can be at 1. Whenever you reach this, you can take 3 steps, so you can be at this position, or this position. I have just explained you using this diagram. So at this position there are 2 possibilities. I can reach to the 3 or I can reach to the 1. At 3 position I can reach to this and this. At 1 I can reach to this and that. So is it possible to reach at the last index from this point? Yes, it is possible. 2 से 3 जा सकते हैं, and from 3 I can go to 4, right? मैं ऐसे भी जा सकता हूँ, 2 से 1 जा सकता है, and from 1 to 1 and then 1 to 4, right? In this case from 3, so 1 2 3 from this point, and from 2 1 2, so 2, yeah, and from 1 it is this, right? So all the ways are getting all the ways are making us to all the ways can reach to up to this point, right? So at 0, and we can't go any further. So for this we can't reach at the end point. You just have to return false. So that's the case, and let's just discuss the logic behind it. Okay, so for index equal to 1, value equal to 3, that's what just I explained. So we are talking about a ladder concept here. And what is ladder concept? So at this point I know I can move to the 2 index, right? This index and this index. So the last point that I can reach is 2. At this index, at this point I know I can move 1 step to the right direction. So the last index that I will reach is 2 plus 1, that is 3. So that means I plus a of I. So we are talking about ladder concept, I plus a of I. At each point I am taking a ladder. 1 plus 3 I can reach up to 4, 2 plus 1 I can reach up to 3, 3 plus 1 I can reach up to 4, right? So ladder should be able to reach at. Now the concept is that ladder should make us to reach, and there is the ladder to at this point, right? But not like case B. So we need to reach at the index or as well. At this case, let's just say there is a ladder between the point and we can reach up to this point, but what I was saying is, let's just say there is a 1 between here, right? And 1. So from 1 I can reach up to this 4, but I can't reach to this one, right? But there is a ladder. I can form a ladder between them. So we need to take care that we can reach every index in between also, right? So check we can reach I with a ladder, or create or ladder, or update ladder. So let's go to the coding part for the more clarity. So this is our question. I have already explained you. Nums true, you can reach to the end. Constraints are in the 10 raised to the power 5 is value and 10 raised to the power 4. So that's it. And let's just go to the logic now and the coding part now. So we are taking a ladder here, right? The maximum reach. So I just mentioned it by 0. At each point, I need to check whether I can reach up to that point, whether I can reach to the ith point. If I can't, then I need to return false. So what does that mean? Ki if I am at this point, can I reach here? Right, reach is 0 and 0 is not less than I, so I can reach up to here. After this my ladder would become 0 plus 2, matlab at this point. Can I reach at this point? First of all, after moving to the next I, can I reach up to 3? Yes, I can reach. So what would be my ladder would now be? So 1 plus 3, my ladder would become 4, so I can reach up to 4. So if that isn't the case, like we can't get any further than this, our reach is not up to that index, we will just return false. Otherwise I can take any jump in between, right? मैं 3 से भी जा सकता हूँ, I can move from 1 as well. So that's the case, and I will update reach at any point. And if I can easily reach to up to the end, I will return true. So that's the logic behind it, and that's the simple code behind it. So let's just move to our next question of assignment. So our question is, search a 2D matrix to write an efficient algorithm that search for value target in a m cross n integer. This integers in each rows are sorted in ascending from left to right. So left to right may they are in the sorted from 1 4 7 11 15, we can see that. And for the next one, integers in each columns are sorted in ascending from top to bottom. So 1 2 3 10 18, we can also see that there is not they are not sorted in this fashion, like 1 4 7 11 15 and then 16 18 something. No, not in this fashion, the row wise or the column wise, right? If they are sorted in some let's just say linear fashion, then we can apply binary search on it and do something. So now the question arises, how to do this, how to do that. So let's move to our notes for that. So yeah, if it would be sorted row by row, I can use binary search on it, but it's not. We know that sorted in this fashion and sorted in this fashion, right? So there is some I comma j pointing to this position. If I am here, if requirement is what is that greater than this value, right? If what I'm telling you by this is, if target is greater than this position, right? If target is greater than this position, so in which direction I should move, right? So sorted, I will move, if I move down the row, that way my value also got increased. If I move this way in the row, that way, like in the column, and that way my value also get increased, right? So in which order should I move? I don't know, I don't have any clarity. So for that, what I would do is I would make this box, and I would start from, let's just say, from the last column or from the last row, so there won't be any two direction, right? So if I can move right or down right, so there are two options to diminish one option: start from upper right or and below right, right? Start from top right. So I'm mentioning you ki why don't we start from the top right? From top right, we, like, if I move to at this point, I would still have an issue ki I will get this. And why don't we start from the top right? If I start from the top right, right, so what would be the case? Ki I'm starting from the top right, and if the value is greater than this, can move this way? No, that would be, my value will get decreased. Can I move down? Yes, in the down my value will increase, so move down, right? If the value of that box is greater, so I need to decrease the value, right? So should I go down or should I go left? I should go left, because in that direction my value would increase. So I can apply that logic, and the complexity would be big of n. No, the complexity won't be big of n. At worst case, I will reach up to that this point, right? So each step I would be move whether a down or a left, right? So for that, the complexity will become big of r plus c, right? Big of m plus n in the worst case. So that's it. Let's look at the code now. So let me just explain you the coding part, where m is the row size, matrix size, m equal to 0, return false, there are not any rows, n equal to the column size, matrix 0 dot size, and r would be 0, c would be n minus 1, that means pointing to this box, right? Row 0, column this at to the 15, while row is less than m, as row will increase, so we are in the range, we need to make sure that, and c is greater than equal to 0. C will move from right to left, so we need to make sure that c is greater than 0. If matrix of rc is equal to target at any point ij, if it is equal to the target, true. Otherwise, matrix of rc is greater than target. Is it if that point, if 15 is greater than the target, which is 5, yes, it is greater than this. So I need to do is I need to move this direction, right? Because in direction I will get the less increasing number. So I will move c minus minus. Otherwise I will do the r plus plus. I can show you a little dry run that if I am in this position, if 15 is greater than 5, yes, move left, c minus 1. 11 is greater than 5, yes, move left. 7 is greater than 5, yes, move left. Is 4 is greater than 5? No, so move down this way, and I found the 5, right? You can take an example. Let's just say 9. Is 15 is greater than 9? No, it is not. This way. Is 11 is greater than 9? No. Is 7 is greater than 9? No. So 7 is greater than 9? No. So move down at this point. Is 8 is greater than 9? No. So move down. In starting left, 15 is greater than, right? So these are the questions that you need to answer, and let's move to the next question now. So our next question is candy, and this is a really interesting problem. So the constraints are, you need to give, there are n number of children and you need to give one candy to each at least. Okay, you have to give one candy to each. Higher rated children get more candy than neighbor. So there are some ratings that are given to the children, and any children with higher rating will get more candy than its neighbor. That means local maximum, some kind of key. He will only look up to its right or left, whether both of these candidates have greater candy than me and what are their ratings is, right? So he will move to the left and right, not to all elements, right? So that means if rating of I is greater than I minus 1, that means he should have more candy than I minus 1 position, right? So C of I equal to R of I minus plus 1. This would be C, my mistake. So candy that I minus 1 has plus 1. If R of I is greater than R I plus 1, right? So that means key the candy rating of I is greater than the from the right one, so it should have candies greater than the right one. So ci plus 1 plus 1. So solve by question requirement. Let's just look up to some logic now. The question is this: 1 2 5 5 2 1. That is the rating given to each student, and our result is, first I need to give one candy to everyone at least, right? So 1 1 1 1 1. Then what I'm going to do is I'm going to literally work on the question and the question part. So it says key and compare it with left or right. So at this position I am comparing it with left and right. Left is not available, so with 2. So from the 2, as 1 is not greater than 2, so the candies amount is 1. 2 is greater than 1, yes it is, so it is 1 plus 1 2. Is 2 is greater than 5? No, it's not, so it keeps at 2. Is 5 is greater than 2? Yes, so it should have candies more than 2, so 2's candy has 2, so 2 plus 1 is 3. Is 5 greater than 5? No, so 3 is the answer. And for 5, is 5 is greater than 5? No, it is not. Is 5 is greater than 5? No, it is not, so it will still have one candy. For this one, is 5 is greater than 5? No, it is not. Is 5 is greater than 2? Yes, it is. So it should have candies plus 1, right? So for this, the candies is 1. So 1 plus 1 is 2. Is 2 is greater than 5? No. Is 2 is greater than 1? Yes. So it should have candies. The number of candies 1 have plus 1, right? So 1 plus 1 is 2. And for the last one, it is 1. Now let's just loop through it again to see is there any change or not. So for this, is 1 is greater than 2? No. So 1. 2 is greater than 1? Yes. And candy should be 1 plus. So it is there. Is 5 is greater than 2? Yes, it is. Candy should be plus 1. And in this way, no. So 5 is greater than 5? No. 5 is greater than 5? No. The candy will still remains it. 5 is greater than 5? No. 5 is greater than 2? Yes. So the number of candies 2 has is 2. So it would become 2 plus 1, 3. And the for 2, it is it 2 greater than 5? No, it is not. So it would still remain 2. Is 2 is greater than 1? Yes, it is. So it will remain 1 plus 1, which is 2. So can you see any change? Yes. In this position 5, there is a change. 2 and 3. And why is that? Now let's think about it. Okay. So for this case, what in all cases what we are doing is 5 is only looking behind, right? 5 is greater than this. There are not any case ki 5 this value is greater than from the right one, but in this position 5 was greater than from the right one, but we haven't any answer for the right one, right? We haven't worked on that part, right? So we haven't worked on that part, so this value got increased, and because of that I need to increase this value also. So these are the two changes, right? Key I can only work on the left side because I have answers for the left side. So why this changes we have already figured out, because on the right there is a change, right? We haven't explored the right part first, only left part answer was available. So why don't we first compare it with the left part only and then compare with the right? Yes, makes sense, because I have only answer for the left one, right? I can't compare it with the right one from something that from the value I don't have, right? So but why start from the last? And this is something that I will answer. So I got the answer key I will compare it with the left only, and after that I will compare with the right, right? So I am saying, I am telling you something, if when we start comparing it from the right, start from the left, start from the last. And why is that? If let's just say you start from the left, in the second comparison, you will compare this one with the 2. There is not any change. 2 with 5, let's just say there is a change between these two. Okay, 2 and 5, let's just say this is 12, so 12 and 5, there is a change between them, so you will do something with this value, right? At this 5, let's just say this is 2, so there is a change between 5 and 2, so you will do something with this value. But that exactly that will make the solution wrong. Why? Because that will completely defeat the our purpose, right? We are traversing on it so that it won't change any value, right? So but this case it happens because this value got updated, so that's why we start from the last. And in this case, when we compare it from the last one, so if there is any change between them, update this one. If there is any change between them, update this one. If there is any change, update this one. So that won't that case won't occur. And let's look at the question, and let's look at the code for more clarity. So this is the code, guys. As you can see, this is a hard problem, and first we are taking the rating size, then a result vector, the number of candidates it would have, and I gave it a value of 1 in initially. Then I'm starting from 1 and I'm comparing with the left, because for left I have the answer we have already talked about. So if ratings of 5 is greater than the previous one, I need to update my value with the number of candidates the previous has plus 1, right? Then in the second iteration, I need to start from the last one and I need to check with the right element. So if rating of 5 is greater than the I plus 1, the last one, if that is the case, I need to increase my candies to the ratings of I plus 1, and the number of candies I plus 1 has is result of I plus 1, right? But I'm taking a max here because there can be a case key in the left direction it is getting more candies from the left side, right? So taking a max, and after that the sum equal to 0, because I need to return the minimum number of candies that you need to have to distribute the candies to the children. Okay, so I need to calculate the total amount of candies, so sum equal to 0, and you are just adding all the number of candies and you are returning the sum. So that's it, guys. Hope you like the section. The assignment link, the notes link, and the Telegram group community link all in the description. You can check them out. I'll see you in the next video.